Seventh topic, limits. Question: prove that limit as x tends to a, x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. How we read this? As limit as x tends to a, x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. Now here is, remember, x minus a, just, and denominator is x minus a. This is trick. X minus a, x minus a. This is trick, remember. Now next is, for the proof of this statement, we use substitution method. Substitution is x equal to a plus h. X equal to, remember, a plus, take h, as x tends to a, h tends to 0. Remember this statement totally. X is equal to a plus h, as x tends to a, h tends to 0. Therefore, equal to, this limit is equal to, now limit changes, h tends to 0, x is a plus h raised to n minus a raised to n upon x is a plus h minus a. Limit after this step changes. Limit h tends to 0, x is a plus h. In this statement, raised to n, bracket raised to n, minus a raised to n, x is a plus h. Now this get cancelled and is equal to limit as h tends to 0. Now this is bracket raised to n. Expand this bracket according to binomial theorem. Binomial theorem is, for these two terms, nc0, a raised to n, nc1, a raised to n minus 1, h plus nc2, a raised to n minus 2, h raised to 2, similar terms, but don't forget this term minus a raised to n. Denominator is h is equal to limit as h tends to 0. Once again this expansion, nc0 a raised to n plus nc1 a raised to n minus 1, h raised to 1, a plus nc2 a raised to n minus 2, h raised to 2, plus dot dot dot, minus a raised to n upon h. Now you know that nc0 is 1. Similarly, nc1 is n. Use these values in the numerator. nc0 is 1, nc1 is n. So write here, h tends to 0, nc0 is, write direct 1 into a raised to n plus nc1 is n, a raised to n minus 1, h raised to 1, plus write this term nc2 as it is, a raised to n minus 2, h raised to 2, plus dot dot, minus a raised to n at the denominator. There is h at the denominator. Now next, remember, we put here value nc0 1. Now 1 into a raised to n, write direct a raised to n. This change remember. NC0 is 1. So 1 into a raised to n, you direct write a raised to n. NC0 is 1. So 1 into a raised to n, write direct a raised to n. So a raised to n and all these terms. If we see then a raised to n minus, this term is plus, this term is minus, get cancelled. Next is equal to limit as h tends to 0. From the remaining terms, take h common. From the remaining terms, take h common. So take here h common in the bracket n. From these remaining terms, h common. So remaining terms n a raised to n minus 1. H common n a raised to n minus 1 plus NC2 as it is a raised to n minus 2. From this term h square, take h common, so remains only h. In this way, remaining terms upon h. From these two terms, h common, n a raised to n minus 1 plus NC2 a raised to n minus 2. From h square, h is common, so there is h plus dot dot upon h. Now, h from numerator and denominator get cancelled. H from numerator and denominator get cancelled. Now put value of h here where it is possible and don't write word limit. Term from numerator and denominator get cancelled. Put value of h0 here. Don't write word limit. So first term is n a raised to n minus 1 plus NC2 a raised to n minus 2, h is 0. Now product with 0. Here also product with 0. Next term product with 0. So all the next terms are 0. Therefore only remains is equal to n a raised to n minus 1. Now put value of h is 0. So this term is 0. Similarly, we put in the next term h0, then that term is 0. Next term is 0. That means all the next terms are 0. Only remains n a raised to n minus 1. So LHS is limit as x tends to a, x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. This is very important formula. Remember this. X tends to a. Here is a. Both the terms have index n. And here is x minus a and x minus a. Then direct put values in RHS. RHS is n a raised to n minus 1. N a raised to n minus 1. Now, so remember this is formula. How we prove it? By substitution. X equal to a plus h, binomial theorem, expansion. Then a raised to n term get cancelled. H from numerator denominator get cancelled. Put values of h 0. Don't write word limit. And we have this formula. Remember this formula. X tends to a is here. LHS is x tends to a, x raised to n. Limit as x tends to a. Limit as x tends to a, x raised to n minus a raised to n. upon x minus a is equal to n a raised to n minus 1. N a raised to n minus 1. This is formula, important formula.